Hello and welcome. It is the first project of Advanced Embedded System Program. This project is aimed to configure the LED blinking periodicity at runtime by changing the T-on and T-off. As shown here, circuit have two switch and two LEDs with their resistors connecting with STM BluePill. So the first switch used to get the value of the T-on and T-off, and the second is like confirm switch. The two LEDs are blinking LED and confirm LED. The project is implemented with four approach. 1. Hardware switch. 2. Software static linking. 3. Semi-hosting low-level system calls like a scanf and printf. 4. ST-link debugger and Keil simulator. Here we have two environment, and we handled it by #if. The first one is called IDE, and the second one is a Makefile, because semi-hosting system calls is not supported by Keil. So here, let's first with the hardware switch ST-link debugger. Our environment here we can see the NVC, the external interrupt and system timer from the system and core peripheral tabs to navigate the application while working. So how we can make this project work? So for the first time we have to press button the number of T-on. And once you're done, you press confirm switch and the confirmed LED will toggle from low to high, and after that you assign the value of T-off and the confirm LED will change from high to low, and only that, the blinking LED will work. If not assigned anything T-on or T-off, the system will not work. We can see the blinking as follows: that T-in watch window here, and we can see down there is the flag has been toggled from high to low, which indicates that state of the LED, whether it's high and low. The second approach by Keil simulator. And here we only interested in system timer registers, and we have the logical analyzer, which not supported in hardware simulation by ST-link debugger. So here we get the value of the blinking LED on port of pin 3. And we assign by ourselves values of T-on and T-off. Hardware switch flag by the simulator and the flip flag. So as you can see here in the logic analyzer, we have the T-on T-off as expected, but not very much, because it's only simulation and the time is not accurate. So here we can get the real value by the value of system timer load register to make sure that our code is working as expected in hardware. But it's not, as in a simulator we can see that the T-on is like 2 seconds, and some in T-off in 1/2 second, and in something is not accurate. So in turn, to make sure that our implementation is correct from Keil simulator by this method. Here if we can get to the calculator form our PC and get the decimal value of the reload system timer register, which can get the value of the T-on and T-off. We can see that the hex value of T-off is equal to 2 seconds, and the hex value of T-on is equal to 3 seconds. And that's one of the reasons that make Keil simulator very popular and powerful, because of the services that can get from it. So here the third approach. Hosting and static linking is only available with custom Makefile, because we can configure the flags or options of the toolchain. Here's the basis of our projects and Makefile commands. First, let's clean the project environment by executing make clean, which delete every toolchain output like map files and so on. And here you can see some files like paths, source file, linker script, and startup code, which all considered as inputs for our toolchain. Path file used to be included within the building process, source files to be compiled, and the C file with T-on and TOF configure file. Here to make sure that we choose our environment to Makefile. So here the first thing we want to compile here all the source files. So then every object file has been generated. Here the build and compile is done, and there are the linker stage to get final executable file as elf.hex.bin and so on. After that we want to download the elf into the debugger, which is here the open-on-chip debugger tool. And to connect with it, use Putty to initiate the communication with Keil IDE. And here the first command to reset all the microcontroller. And want to burn our code or download it. But we have to pass the option of erase it before you download your file. And after that we have to enable the semi-hosting by that command. A semi-hosting is like IDE console. Here we have hardware switch and semi-hosting and SW static linking choice. Here we can make the hardware switch again. Repeat the process once again, T-on and T-off assigned with switch 1 and confirmed it by switch 2, and here we go. Our code is working as expected. If we decide to choose another option here, let's choose semi-hosting. Here, it asks the user and get the input for time on and time off. As graphical user interface. Let's try 4 second for T-on and 2 second and T-off. Here we can see that the code is working as expected. This features can be implemented to send data from PC to LCD, UART, and any interfacing peripheral, and it quite a hack tool in embedded system world. We want to try other parameters and ask the user for the input again. For example, T on and the T off is 5 seconds and 1 second. And then once again, this code is working as expected. And with our final approach is software static linking, is how to change with just the configuration program file without modify the application source file. Let's execute the static linking with predefined configuration into our microcontroller to make sure that linking is done correctly. So here we go to the configuration file. Change T on and to T off, for example, 6 second T on and 2 seconds T off. And then compile the configuration source file. But before that, we have to delete the old object file of the configuration file by that command. Then delete the elf and every image like hex or bin by that command. Then compile the configuration file again. Only that link that object file of the configuration file with the application objects file. So the linker can resolve all the symbols and relocated it into the microcontroller memory with linker script as input and get the executable file. We make the same process again. We'll go to openOCD debugger tool and connect it with Putty. And we enabled the semi-hosting again. Semi-hosting is only working in debugging tools like openOCD debugger. So we want to download our new executable file and then enables a semi-hosting. Reset the microcontroller. Then wait for the interface with the application. When it shows, choose the static linking option. And we can see that in our hardware. It's working very well. That approach is used in the embedded system industry. For examples, you the customer and the company gives you the configuration file and the application object file, and to make change in the application, you have to change the configuration file and you want to linking it together. So here everything is done without any edit or modification to the application source files. So here everything for today. So goodbye and good night. Thank you.